In this video, we're going to continue our discussion of type checking in COOL with the rules for type checking methods and method calls. So here's the situation when we want to type check a method call. Let's say that we have a dispatch on some expression E0 and we're calling some method named f, and we have some arguments E1 through En. Well, so clearly we're going to type check E0 and it's going to have some type T0, and similarly we're going to type check all of the arguments and they're going to have some types. And then the question is, what is the return type of this method call? What kind of value do we get back after we call this method? And as you can probably see, we're in a very similar situation here that we were in before when we were trying to type check a variable reference. We have this name f, and we don't know anything about what it does. We don't know what the behavior of f is, and unless we have some information about f's behavior, we can't really say what kind of value it is going to return. An added wrinkle in COOL is that method and object identifiers live in different namespaces. That is, it's possible in the same scope to have a method called foo and also an object called foo, and we won't get the two confused. They are different enough and used differently enough in the language that we can always tell when we're talking about the object foo and when we're talking about the method foo. But what this means, in effect, is that there's two different environments in COOL, one for objects and one for methods. And so in the type rules, this is going to be reflected by having a separate mapping, a separate method environment that's going to record the signature of each of the methods. And a signature, this is a standard name that you'll probably hear used in other contexts, but the signature of a function is just its input and output types. And so this table, M, is going to take the name of a class, it's going to take the name of a method in that class, and it's just going to tell us what are the argument types of the method. So all but the last type in the list here is one of the argument types of the method, and then the last type is the result type. That's the type of the return value. So the way we're going to write the method signature is just as a tuple or a list of types. The first, all but the last one taken together are the types of the arguments in order, and then the very last one is a type of the result. And so an entry like this in our method environment just means that f has a signature that looks like this. It takes n arguments with the respective types and it returns something of type tn plus 1. So with the method environment added to our rules, now we can write a rule for dispatch. So notice, first of all, that we have these two mappings, one for object identifiers and one for method names on the left-hand side of the turnstile. We have to propagate that method environment through all of the typings for the sub-expressions. And for the case of method dispatch, we just type the type of the expression that we're dispatching to, E0, and all of the arguments, and get types T1 through Tn. And then we look up the type of f in the class T0. So what class are we dispatching to? Well, that's going to be to the class of E0. And so where do we look up M in our environment? Well, there better be a method called f defined in class T0, and it must have some signature with the right number of arguments. And then the actual arguments that we're passing, the E1 through En, their types have to be subtypes of the declared formal parameters. So here, the signature of f says that, for example, the first argument of f has type T1 prime, and so we're going to require that the type of E1 be some type T1 such that T1 is a subtype of T1 prime, and similarly for all the other arguments of the method call. And if all of that checks out, if f has a signature like this and all these subtype requirements on the actual arguments and the formal arguments match, then we're going to say that the entire expression, this dispatch, returns something of type Tn plus 1, the return type of the method. The typing rule for static dispatch is very similar to the rule for regular dispatch. So recall that syntactically, the only thing that's different is that the programmer writes the name of the class at which they wish to run the method. So instead of running the method f as defined in the class E0, whatever that class happens to be, we're going to run whatever the method f happens to be in some ancestor class of the class of E0. And how is that expressed in the type rules? Well, once again, we type E0 and all of the arguments. And now we require that whatever the type was we discovered for E0, it has to be a subtype of T. So T has to be a ancestor type in the class hierarchy of the type of E0. And moreover, that class T had better have a method called f that has the right number of arguments with the right kind of type, such that all the type constraints work out, that the actual argument types are subtypes of the corresponding formal argument types. And then if all of that is true, we'll be able to conclude that the entire dispatch expression has a type Tn plus 1, which is the return type of the method.